Hey scholars, today we're going to be talking about lesson 13 and lesson 14 for math. Now, I'm going to be shooting this in two different videos, so if you see me with a different set of clothes or anything, that's why. So I'm going to connect my iPad to the screen, and we're going to go ahead and we're going to look at lesson 14. As soon as, okay, good. There we go. So lesson 14, we're continuing with discs like we worked on the last couple. So this is module 3, lesson 14. And our objective is to model numbers with more than 9 ones or 10s. There's also a little more to it, but as far as I can see this part of the lesson, we're only going to focus on this part of the standard. And so what I'm going to do is I want to show you what happens when we have a certain amount of chips. So I'm going to draw a 100 chip here, and then I'm also going to draw 10 chips. Remember, they need to be close to the same size, but they don't have to be exact or perfect. As long as I can see that you have that idea. All right, and then we also are going to, actually, we're not going to do that yet. So let's look at this 100. So when I have 10 chips, I have shown you that we can take these 10 we can take these 10 chips and we can turn it into a 100, right? Well, what if I told you we could do the opposite? So instead of turning our 10 chips into 100, what if we break this 100 up into 10 chips? Because if 10 chips can turn into 100, that means a 100 can turn into 10 chips if we need it to. Now, we could also do this with a 10 chip. What would one 10 chip turn into? One 10 chip would turn into 10 ones. And notice I'm still drawing them like a 10 frame because that is one of the easiest ways you can tell how many chips you have and how many chips you need. So let's go ahead and review this part. If I have one 100 chip, I can turn that into 10 chips. And if I wanted to turn this 10 chip into ones, I can do that. So I'm going to break this 10 chip up into 10 ones. Perfect. Okay. So we want you to take one value and break it up to 10 of lower value, or take 10 of the lower value and combine it to make one of the bigger value in this lesson. So what I'm going to do now is I'm going to show you some examples. So let's go ahead and look at our first example, which is going to be 16 equals blank tens blank ones. So what I have shown you is you can look at the place value of the numbers to be able to identify how many are in a certain set. So 16. How many tens are in 16? 1. How many ones are in 16? 6. So we have 10 ones, or sorry, we have 1 10 and 6 ones. 10 plus 6 makes 16. What if I told you we can actually solve this a different way? So if I don't give you the option of tens, what could we do? We could have ones, just ones. So how would we go from 110 to 6 ones? and convert it to ones? Well, like I showed you earlier, a 10 can be converted into 10 ones. So let's go ahead and cash in this 10 chip and make it 10 one chips. So we're going to add 10 ones. So if we have 10 ones plus 6 ones, we have 16 ones. All right. Sorry about the pause. I had a phone call I had to take, but we're going to get back to where we were. You might not even have noticed because I was able to stop the recording. Okay, so let's get back. And so we had 16 equals 16 ones. So now we're going to look at the next problem, which is going to be a little tougher, but that's okay. We work hard and we're going to do our best. So we're going to have 217. The first thing I want you to do is tell me how many hundreds are in 217, how many tens are in 217, and how many ones are in 217. Well, we can do the same thing where we look at place values. So 217 has 2 hundreds, 1 10, and 7 ones. Now that's not the tough part. The tough part is what happens when with 217, we only want to know hundreds and ones. So we don't want to know tens anymore. We only want to know hundreds and ones. Well, it's going to be the same thing we did last time where we converted these tens into 10 ones. So let's skip count from 7 to by tens. So 7, 17. So instead of 10 ones and instead of 1 10 and 7 ones, now it's going to be 17 ones. Is the 2 going to change? No, the 2 will not change. Okay, cool. Okay, now there's only going to be one more we're going to look at. And this one, I'm going to let you guys try after I show you how it works, okay? So we have 407, nope, not, we have 473, and that's going to equal blank hundreds, blank tens, and blank ones. So 4 hundreds, 7 tens, and 3 ones if we're going by what we've been doing. Now, this is the challenge part. What if we're looking for 473 and we have blank tens and blank ones? So we're not looking for hundreds, we're only looking for tens and ones. What can we do to figure that out? Well, first, let's draw our hundreds pieces. All right, so we drew our hundreds pieces. Now, since we're not looking for hundreds and we're only looking for tens, what do we need to do with these hundreds pieces? We need to convert them to tens. So how many tens is 100 worth? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to go ahead and zoom in and draw my tens really quick. 10, 10, 10, 10, 10, 10, 10, 10, 10, and 10. Do we need to do it with more than just that 100 piece, or is that one okay? Well, since we're only looking for tens and ones, we have to convert all these hundreds. So through the power of cutting, I'm not going to draw these ones by hand as well. So now we converted our 400s to 10s. And don't forget about the 7 10s we also have originally. Now what I want you to do on your seesaw is I want you to answer how many 10s and 1s are in 473. All right. Okay, this will be it for this lesson, and I will be back instantly for you guys for the next part of the lesson. All right. Thank you, and see you in a couple seconds. All right, we're going to start our lesson 15 now. So lesson 15 is kind of interesting because what we're going to be doing is we're going to be applying the knowledge, or we're going to be using the knowledge we learned in the last couple lessons to be able to work on a multi-part problem. So our objective is to explore a situation with more than 9 groups of 10. So in order to do that, we're going to be working with some word problems. All right. So pencils come in boxes of 10. How many boxes does Erica need to buy if she needs 127 pencils? So there's a lot of ways to solve this question, but there's one important thing you need to know. You need to go over the amount of pencils you need to be able to count the boxes correctly. So when you get to 120, you'll have to go up because we have to get past 127 to get the right amount of boxes. So I'm going to use the discs to solve this. So I have 127 pencils. Notice I'm writing my discs out. All right, my question is it easy to figure out how many pencils I need if I have a 100, 2 10s, and 7 1s? Remember, pencils come in boxes of 10. So what should I do with my 100s chip? And everyone, oh, hold on, I'm going to stop my share. Everyone say hi to Mr. Sleepy. He's a bit hungry, so he's been bothering me. All right, we'll go back now. Okay, logging back on, logging back on. There we go. So what we need to do is we need to turn this 100s chip into 10 chips. So let's go ahead and do that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we exchange this 100 chip for 10 10 chips because there are 10 10s in 100. So now I'm going to put a big red X through this because we don't have that anymore, and I don't want you to think we do, okay? Now, if each pencil box is 10, all we have to do now is we just have to count our numbers, and then we'll be able to find how many boxes we need. So we have 10 pencils, 1 pencil box, 2 pencil boxes, 3 pencil boxes, 4 pencil boxes, 5 pencil boxes, 6 pencil boxes, 7 pencil boxes, 8 pencil boxes, 9 pencil boxes, 10 pencil boxes, 11 pencil boxes, 12 pencil boxes. So we have 12 full pencil boxes we need. But don't forget about these 7. We'll need another pencil box for that one because we need to count those 2. Okay? So we need 13 pencil boxes. So I'm going to write that here. For A, we need 13 pencil boxes. Let's go ahead and look at the next one. How many pencils will she have left over when she gets what she needs? Well, I like to be as efficient as possible, but you don't have to be efficient with how you solve these right now. You don't have to solve these quick. I just want you to try to solve them with whatever strategies you can think of. But a strategy I have is I'm going to just copy paste this. And for you, you don't have to necessarily copy paste it. You could just write the same thing. I just wanted to do it in a different part of the question. Now, in order to make a complete 10, what can we do? Well, these are all complete 10s, so we don't have to worry about them, right? But these ones are not a complete 10. So why don't we create a different colored chip to show what we're missing? So these 3 pencil boxes in red are going to be the pencil boxes. I mean, these 3 pencils in red are going to be the pencils that she didn't use, okay? So I kind of gave the answer, but so that means everything in red is going to be an extra pencil. So there are 1, 2, 3 extra pencils. So for B, there are 3 extra pencils. All right, and now there's a part C. Oh my goodness, all of these problems for one problem. All right, let's read this one now. How many more pencils does she need to have 200 pencils? Well, I want to use that line method we learned a couple days ago. You can do whatever strategy you want as long as it works for you. You could count up, you could go. You just have to remember where we started. So we have 130 pencils currently. You could skip count. You could go 140, 150, 160, 170, 180, 190, 200. I counted 7 tens. 7 tens equals 70. There are 70 pencils we need to get to 200. But I'm going to use something a little more visual. I am going to use that number line we learned where we use the arrow method and we skip count. So if we're looking at 130, because we're at 130 because that's how many pencils that we got when we bought them. And we want to get to 200 because it's asking how many more pencils does she need to have 200 pencils. So let's use that method. Remember, I like to start from smallest to biggest. So let's start with the ones. Do we need to add any ones? Look at, we're already at 0. We're already at 0. Do we need to add more ones to get to the 200? Nope. What about tens? Do we need any tens? We do. So let's start with tens. So we have 130, 140, 150, 160, 170, 180, 190, 200. So we have 10, 10, 10, 10, 10, 10, and 10. And now we can just count the tens. So we have 10 more, 20 more, 30 more, 40 more, 50 more, 60 more, and 70 more. So she needs 70 more pencils. All right. And that question you did earlier on Seesaw is going to be the only question for today, just so you know. All right. Well, I hope this one was interesting because it is different than the other lessons because all we did was work on one problem. But that's how math is sometimes. So goodbye and enjoy your day and watch the rest of the videos you need. See you later.